Hello, this is Tyler Beamer from Haywood Community College. This is an instructional math video for Math 152, Statistical Methods 1. The purpose of this video is to describe how to find correlation coefficient and linear regression models on Excel. Okay, so I'm going to be working off of the example in the notes. So if we look at the 10.2 notes on correlation, we've got an example using the data here for the opening bid suggested by the auctioneer and final winning bids for several items that were auctioned off. Okay. And I've described in the notes a few different ways to determine if there is a linear correlation between paired sets of data. Basically, we're going to be running a hypothesis test, and here is the null and alternative hypothesis for that test. The null is stating that rho, and this Greek letter that looks like a P is rho, is equal to 0, which would state that there is no linear correlation, and rho would be the population correlation coefficient. So that's what we're going to assume is true for the null. And then the alternative is that it's not equal to 0, which means that there would be a linear correlation. Okay. And we're using alpha equals 0.05 in order to do that. I have described how to do this using the graphing calculator in these notes. But however, if you do not have a graphing calculator, then you would probably want to use Excel. So that's what I'm going to describe as how we can do this in Excel. All right. So first thing that we want to do is find R. And like I said, R is the linear correlation coefficient for the sample data. R is going to be a value between -1 and +1. The closer R is to +1, the stronger positive correlation, which means we'd have positive slope. Closer R is to -1, stronger negative correlation, which means we would have negative slope. Okay, and then the closer R is to 0, then that would describe that there's no linear correlation between the data. Okay, so we've got examples here of data that would have a positive correlation, so that would look like this graph here, where you've got the data points increasing from left to right, so that would be representative of positive slope. Negative correlation, we've got the data points decreasing from left to right, so that would be representative of negative slope. R equal to 0 would be something like this, where you just have random points everywhere, and when you look at a scatter plot, you can see that there's no correlation. Okay. All right, so let's go back to our data. All right, so let's go to Excel. I already have the data in here. I think it's important to graph the data first. So if we click Input, well, let's highlight our data first. Input, or Insert, sorry, after we highlight it, and then we can do a scatter plot, and we can get an idea of our data, kind of get an idea of what we're looking at here in terms of if there is a linear correlation before we even calculate R. Right. So this point here is the point 1500, 650. This point here is 400, 275. So basically this data is paired, and then each of those pairs are plotted on our scatter plot. And of course we can label this. So basically we're comparing the opening versus winning bid. So let's put in go to our chart tools and add some elements here. Let's add some labels so we can make sure that we understand which axis is describing which category of our data. So we've got the opening bid, and then over here On the vertical, we've got the winning bid. Okay. Okay. So a scatter plot's always nice to plot that. If we want to find the value for R, we can do that. So let's label this R correlation coefficient. Okay, and then if we select a cell, go up here to equals, and then we actually do formulas, more functions, statistical, and then find correlation. We can actually get a correlation coefficient this way. So we've got to select two different arrays. We need array 1, which would be our x values, and then array 2, our y values, and then select OK. And then that gives us a value for R, right? So it looks like our R value is pretty close to +1, which we can see from our scatter plot. That's an indicator that we probably have a strong linear correlation here with our data increasing left to right as we go on our graph, which we can see from our scatter plot. Okay. In terms of the hypothesis testing, if we want to make sure that we get an accurate estimate as to whether there is a linear correlation here, we can use our table for critical values, and this is out of our textbook. So table A5, critical values of the Pearson correlation coefficient. Okay, so we would need to determine the value for n, and that in this case would be 5, since we have 5 matched pairs. So basically 5 items were auctioned off, and we collected data on those 5 items. And then alpha was indicated to be 0.05 in our problem. So if we compare n of 5 and alpha of 0.05, we get a critical value of 0.878. So as long as our value exceeds that critical value, then we can conclude that there would be sufficient evidence to support the claim that there is a linear correlation between the opening bid suggested by the auctioneer and the final winning bid. So using the Pearson correlation coefficient R critical value table, then that's one way to determine the results of our hypothesis test. So then we would reject the null in this case, that rho is equal to 0, and then accept or state that there's evidence to support the alternative, that rho is not equal to 0. Okay, so that's one way that we can determine whether we have a linear correlation. Another way is to use a p-value method. Okay, so Excel will also help us to do that. If we go to data and data analysis, and we've already discussed how to add in the data analysis tool pack to Excel. I'll just show you that once again. If it's not there, you have to do this once. So go to File, Options, Add-ins, Analysis Tool Pack. Go. Make sure you click Analysis Tool Pack. OK. And then when you click on Data, you should see Data Analysis. So if you don't see it, then that's how you add in that program. You should only have to do that once. Alright, so click on Data Analysis. We could also get correlation by using the Data Analysis Tool Pack. So if you click on Correlation here and select OK, and the input range is going to be all of our paired data. And then the output range is going to be the place on our cell or on our spreadsheet that we want to put our results. So click OK. Output range. Okay, so let me try this again. So input, highlight the data, output, okay, give it an output range. There we go. And you can see we get the same value here. So either way you want to do this. Okay. We can also use this data analysis toolpack and do a simple regression analysis. So if we click on regression and OK, and then we want to input our Y range, and I'm going to actually select the label with the Y range and do the same for the X range. And then I'm going to click labels, and if I'm going to highlight the labels, I want to make sure that I click labels so that it uses that in my results. Then find a empty spot on the worksheet for your output range, somewhere we can put our results. And then let's also get all of these plots, especially for residuals. We'll talk about that here in just a minute. So click OK, and then we get a ton of information here. So alright, if we notice that multiple R is our R value here, right? So this is R squared, so if I square root that, then I should get the value for R. So notice that's the same. So there's 3 different ways to find R on Excel. Okay. And then if I look over here at my ANOVA output, okay, then I can see that I have significance for F, right? And that's actually going to be my p-value from our t-test, right? And we can use that to make a judgment call whether we have a linear regression. Okay, so notice that our p-value is 0.014574, and we can compare that to alpha, which would be less than alpha. Therefore, that gives further evidence that we would reject the null that rho is equal to 0, right? Which we've already stated from using our critical values table, but this is a p-value method. So basically this here is our p-value in order for us to make that determination. Okay. Alright. You could also find that t-value by doing a t-statistic and then using your t-table to determine p-value. If you're using Excel, however, we're using an f-statistic and an ANOVA table. So it's slightly different, but it gives us the same results. So 2 different ways of the same means of doing that. Alright. Other important information that you get from the Excel output is a line of best fit, and this line of best fit is essentially a linear equation that would go through the majority of these data points, and we can use that line of best fit for prediction. So we are given the 2 pieces of information that we need for that, and we've got our equation here, y hat, right, which is our predicted y values, and that's going to equal to our y-intercept, which is this value here. Okay, so negative 4.62185 plus our m, which is slope, times x, and our slope is located right here. So that's the value for our slope. So 0.429097 x. So basically we're following y equals mx plus b here, where this value in our Excel output is our y-intercept and this value is our slope. And all of this information here, this is confidence intervals for those values, and this is a t-statistic and p-value, a t-test for our intercept and slope, describing how accurate they are, I guess, in using those in our linear regression equation. Okay, but that linear regression equation can then be used to make predictions, okay, for future values that we don't know. So let's say we were going to do this auction again later. We could use this regression equation, input the opening bid in for X, and then determine how much money they would then receive in the winning bid for a certain item, so that they can then prepare to try to get an estimate before they auction off items as to how much money they would make. Okay. We also get a lot of really cool graphs here. We've got a residual plot. Residuals, I didn't mean to move that. Residuals describe the difference between the actual value and the predicted value. Okay. So if our residual is exactly 0, then there would be no difference between the observed value and the predicted value from our least squares equation that we just found. Okay, you would generally like to see this plot kind of scattered, where you've got data points pretty much all over the place. So our residual plot doesn't look too horrible here. We've got other plots here. We've got our line fit plot where we're plotting winning bids and predicted winning bids. So this is once again another way to describe residuals. So if we've got these blue squares and these orange squares exactly on each other, that means the winning and predicted bid were really close, if not the same. And then we've got a normal probability plot here, which describes normality within our data once again. So Excel gives you lots of those, and we're not going to get too in depth with all of those pieces of information in what we're doing in our particular course. The most important things for our course is being able to find R, describe whether we've got linear correlation, and coming up with this regression equation. Okay. We can also get that regression equation on our graph if we right click in our points and then hit add trend line. We can get a linear trend line, which is going to be the line of best fit, and then we can also display the equation and display the R squared value on the chart. If we click those there, and then we should get that information. And so that's the same values that we're getting for our least squares equation line. If we compare that to what we got down here, that's the same equation. And then our R squared value is the same. If we square root that, we get R. But then it graphs that line on our scatter plot, so we can see that line does go through the majority of our data points, and then we can use that to then make predictions about future values. So, alright, so hopefully this video helps you out in using Excel to do some analysis with linear regression. And as always, if you have any questions, please ask. Alright, have a great day.